So we're talking about inverses today, and basically an inverse is something that undoes something. So when you were in Algebra 1, you learned an inverse operation. Like if you had addition, subtraction took care of it, right? Undid it. Those are inverse operations. Today we're going to talk about a whole function that undoes another function or a relation. Your learning targets are to know whether a function is one-to-one and what that means. Find the equation for an inverse. It says including domain restrictions. And then I can graph a function and its inverse. It does list here, you can verify two functions are inverses or not, but I will tell you I didn't put that on the summative. It's an easy thing to do. I just thought we had enough else going on this. Okay. I apologize that you have to do some writing here, and you can kind of pick and choose how you word this on your own notes. But what is the inverse of a relation? Okay. It's a relation that reverses or undoes another relation. So if you had an equation that was like x divided by 2, 2x would be the inverse. They would undo each other. The inverse of a relation R is written as, I don't know why they use R, because we feel like we already use an R for negative numbers, for all real numbers. In our book and most of the materials, it will list the function as f of x, and then its inverse as f of x to the negative 1. Please note that has nothing to do with like moving a variable to the denominator, not that kind of a negative 1. Do you guys know what I'm talking about when you have a negative exponent? Like if I wrote x to the negative 2, it means 1 over x squared. You remember that stuff? This has nothing to do with that. It's simply a notation. I don't know, again, who came up with this funky stuff because it is confusing. But that's the notation for inverse. And honestly, I don't care if we don't use their proper notation. Give the inverse of this relation below. Okay, I wrote down here at the bottom in green, an inverse switches the x and y values. So it also switches the domain with the range. The range becomes the domain. And the graph will reflect over the line y equals x because you are interchanging the x and the y. So with that helpful hint, can anybody tell me what they think might happen to these ordered pairs? 0, negative 7 is going to become, yep, you're just interchanging or switching the x and the y. Negative 1, 2 will become 2, negative 1. Negative 4, negative 2 will become negative 2, negative 4. And 6, 3 would become 3, 6. And I wrote that way too big to fit in there, but. All right, so every relation, you can probably find a way to undo it with a separate equation. But we want functions, and functions have an inverse function if they are what is called one-to-one. Two relations are inverse relations if and only if one relation contains the element BA and the other contains the element AB. So you're just switching them. If the inverse of a function is also a function, then you use this notation that I talked about here. A function has a one-to-one relationship, okay, if the relation and its inverse are both functions. That sounds really confusing. It even sounds confusing to me when I read it. But you say it is a one-to-one function if when you find its inverse, that is also a function, meaning it passes what test? Do we test for functions? Vertical line test. So if the original one is a function, it is also called a one-to-one function if its inverse will pass the vertical line test. Now, that test for whether something is one-to-one, can I go to the next slide, guys? Okay, Rena, I'm waiting. You go. You good? Okay. The horizontal line test is what will help us determine if a function is going to be one-to-one, okay? So horizontal line test will decide whether it's one-to-one if it passes, okay? Recall the vertical line test is determined whether a relation is a function given a graph. The horizontal line test is used to determine whether the inverse will be a function. Both the relation and its inverse must be a function in order for it to be called one-to-one. So, if a function passes the vertical line test, if a graph passes the vertical line test, it's a function. If it also passes the horizontal line test, meaning no horizontal line crosses it more than once, then its inverse will be a function. All right, it says a function has an inverse function if and only if each horizontal line intersecting the graph is at most one point. This is known as a horizontal line test. If a function passes the horizontal line test, it is said to be one-to-one because every x value is matched with exactly one y value, meaning neither the x nor the y repeat, which makes the inverse a function also. All right, this sounds all complicated, but this is clearly passing the vertical line test. Would it also pass the horizontal line test? Yes, so this is one-to-one. Okay, which means it is a function and its inverse would be a function. All right, number 2 is a cosine graph. It passes the vertical line test. Will it pass the horizontal line test? No. So this function is not one-to-one, but I'm going to tell you that when we get to inverse trig functions, what we're going to do to make this one-to-one is we're going to cut off parts of the graph and we're going to restrict the domain. If we talk only about this little chunk, we can make it one-to-one. Does that, okay? So that's going to happen later this year. So it is possible that when you get to calc, you'll take some of these functions and restrict the domain so that they are one-to-one. All right, what about this guy? I know this is confusing because it looks like it has horizontal and vertical pieces, but there's actually an asymptote here that it's not ever getting perfectly straight, and there's one here, it's not. So this is a yes, okay? It is one-to-one. It's hard to tell with those. Those are rational functions, and we're going to spend a lot of time on those today because they're the tricky ones to find the inverse equation for. All right, what about this guy? It looks like it's vertical right here, but it's actually not perfectly vertical. So is it passing the vertical line test? Yes. Horizontal line test? Yes. This one is yes, one-to-one. Can anybody tell me what one-to-one means again? Other than the fact that it means it passes both the horizontal and vertical line test. It means yes. Okay, that this is a function whose inverse will also be a function. Is this a function? No, this is not even a function. So it can't be a one-to-one function, okay? Is this parabola that you probably don't have a function? Okay, this is a function, but is it one-to-one? No. Okay? So therefore, its inverse, which would, by the way, look like this, is not a function. unless we restrict the domain. Like we could talk about the left half only or the right half only, and then it would be 1 to 1. All right, so to find an inverse, the big steps, these are all of the steps, but it says to find an inverse function, follow these steps. Use the horizontal line test to confirm the inverse function exists. Replace f of x with y, and then you interchange the x and the y. That's the big one, okay? You want to switch the x and the y, and then you have to go back and solve for y all over again. And then if it is 1 to 1 at the end, they want you to use this notation, but I'm not going to be picky on that. And if it ended up with a x in the denominator or a radical, you would need to talk about domain restrictions. So the big deal is that you switch the x and y, and then you have to solve for the y again. So you can just watch on this one. This one says right now, y equals 1/4 x plus 3. Okay, that's a line, so I'm pretty confident that it passes the vertical line test there and the horizontal line test, right? What you would do to find the inverse is you switch the x and the y, and now you're trying to get the y by itself. What order do I use to get the y by itself, guys? What do I do first? Subtract 3. And then how do I get rid of a times 1/4? This is all worked out for you over here already, but to get rid of a times 1/4, I do what? Multiply by 4/1, which is dividing by 1/4, multiplying by 4/1, okay? So if I decide to multiply this side by a 4/1 and this side by a 4/1, this would just be left with a y, and over here, you could distribute or leave it, I really don't care. They did 4x minus 12. And then because it was 1 to 1, they went ahead and said, therefore, we should write it like this. Do you not have this example already? Okay. I just see a lot of people writing, and I was trying to just let you pay attention without writing, but anything you want to write, that's great. So that's why they got to this f of -1 of x. I will accept this on the quiz if you don't remember to do that last step, okay? They get more complicated, but let's just run through a couple examples here. If you graphed this, y equals 2x minus 4, would that pass the horizontal and vertical line test? Yeah, linear functions, yep, we're good, unless it was a horizontal line. So how do we go about finding the inverse then? This is okay to do because it has an inverse that is a function. Anybody? Yep, switch the x and the y. Okay, how do I get the y by itself? Add 4 over to, I'm adding 4 to both sides. I should probably write it, but it will become an x plus 4 over here because it is not like terms, can't combine those. And then the last step, divide everything by 2. And I don't care if you leave this x plus 4 over 2, or you think of it as a linear equation and you say there was a 1 here, so I have a 1/2 x plus 4 is divided by 2, so I have a 2. And that's equal to y or f of x okay, you can write it as x plus 4 over 2 or 1/2 x plus 2, it's equivalent. All right, good news. What is the shape of number 5? Talk to me about transformations. It's a parabola that has shifted right 1 and up 2. Okay, but does that pass the horizontal and vertical line test? No, so it says determine whether f has an inverse function. the inverse of this, which it has an inverse, but it would not be a function, so we don't have to find it. Inverse is not a function. Can I just for fun show you how you would isolate that? Let's think about this for a second. You would subtract the 2 to the other side. Everybody with me? How would you get rid of the squared? You'd square root both sides, and you would have to remember a plus or minus. So then you'd have plus or minus the square root of x minus 2 equals y minus 1. So the last thing you would do is add 1 over to the other side. So you could write it either like this or put the 1 out in front. But it's not going to give you a function, so it said we didn't even have to do it. I just wanted to show you the inverse steps. Okay, we good? All right, this is where it starts getting crazy. You can graph this if you want. Anybody want to type that in their calculator real quick? 5 over the quantity x minus 2. You will need parentheses around the denominator for it to graph correctly. Five divided by the quantity, was it x plus 2, guys? See, I knew I'd remember it wrong. And then if I do a zoom 6, this is what it looks like, but it is passing both the horizontal and vertical line test, okay? So it passes, so we can go ahead and find the inverse. This is really y. Everybody okay there? So when I switch x and y, it will become x equals 5 over y minus 2. Now, any ideas? Because this is where stuff starts getting ugly for students, and they do some crazy stuff. What we actually have to do, yeah, we're going to kind of do the cross multiply thing, or we're going to multiply both sides by a y minus 2. I like to think of it as cross multiplying. Put this over 1. So we're going to multiply an x by the y minus 2. And that's going to equal 5 times 1 going this way, or 5. Now, we need to get the y by itself. Couple ways we could do that. Do you want to distribute it, or you don't want to distribute it? Okay, if we don't distribute it, what would be next? Yep, divide by x. Then we'd have y minus 2 equals 5 over x. And then all we'd need to do is what? Add 2 over there. That would get rid of it on this side. So we have the inverse function is 5 over x plus 2. Can I talk to you about if we had distributed it, what would have happened? Okay, when we were here, if we had distributed that x, you'd have xy minus 2x. What would you do next to isolate y? Add 2x over to the other side, and then divide everything by x. Are those the same thing? I didn't write this one very well. This is a big plus 2 on the back. I made it look like it was in the denominator. These are actually the same, okay? Because this is with a common denominator, this is without. It is very hard for students to tell equivalent forms by visualizing them sometimes. That's the good news. That's my job, okay? The same way in a minute we're going to get things like this. X minus 1 over 2x minus 3. Well, that is actually equivalent to negative x plus 1 over negative 2x plus 3, because all you've done is change all the signs, top and bottom. So my job is to figure out when you turn it in and I grade it, whether they're equivalent, okay? You don't have to worry about it. I think, on the answer key, try to write a couple equivalent forms so that you wouldn't get freaked out if you got a different form. All right, is this one done for you in this little example on your notes? No? Okay, do you have a place where you could write this anywhere? They get tricky, okay, because there is a y in two places when you have an example like this. As soon as you switch x and y, see there's going to be a y up here and a y down here. And that should be a 2, not a TO, sorry. When y is in two places, you'll need to isolate the y's on the left and factor. That's the hint here. But all of the steps are still switch x and y and then cross multiply. Get all the things with a y on one side. And actually that means everything that didn't have a y, you move to the other side. Then you're going to have to factor, okay? There's no shortcut. It's not a hard factoring. You're just going to factor out the common to y. And then you divide so that the y will be by itself. That'll make more sense when we do it. Let me talk through this example over here real quick. Okay, they switched the x and the y. Then they cross multiplied. 7 times y minus, or x times y minus 7 became an xy minus 7y. That's already distributed right there. And then this was just 2y plus 5 here. Then they subtracted the 2y over to this side, so everything was a y was over here, and they added the 7x back to this side so that things that didn't have a y were on the other side. Then they factored out the y from the side that had the two y terms, and finally they divided by the quantity x minus 2. All right, that's just an example. We're going to do these examples, and these will be your examples, okay? So how do we start off? Okay, can I just say that that's y rather than rewriting it again? And then we're going to switch them, so we will have x. I don't want to put an equals there. What is that? X equals y minus 1 over 2y plus 5. Now, if your x's and y's are a little hard to read because you chicken scratch, try to make your y's a little clearer, okay? Whether you give them a longer tail or a curly tail or whatever you do, make sure you can tell what's an x from a y. All right, what was the first step? Switch x and y and cross multiply. So 1 times y minus 1 is just y minus 1. It doesn't matter which way you go. It doesn't matter which way you go first. I could have put this on the left side and I would get the same answer. X times the quantity 2y plus 5. Now, when you get good at this, it's okay to distribute it all at once. I'm going to write it out for this example. But that is the next thing you're going to do is distribute over here. If you didn't already do that. Whoops. X times 2y would be 2xy. Everybody okay there? And then x times 5 would be a 5x. All right, now we need everything that has a y on one side. I'm going to move to the left. What do I need to move over to the left? A 2xy, and how am I going to move it? Subtract it. Now, can it combine with anything that's over there? Is there another xy over there? No. Would it be okay with you if at the same time I got rid of this minus 1? Okay, because it's got to move to the other side. So I'm going to add 1 over here. Now, I have a y minus 2xy. And over here, I'm left with a 5x and a 1. Can I add those together? Nope, not like terms. What's next? Factor out the y on the left. If I take a y out, please don't tell me it's just negative 2x. Remember, you're dividing each of these by y, and y divided by y is 1 and then a minus 2x. Is everybody okay there? Because if I distributed it back, it would have to go back to the same thing. And the last step, well, unless you're going to be fancy and put the notation step in, what do we have to do? Trying to get the y by itself, so we got to divide by that 1 minus 2x mess. So left is y equals 5x plus 1 over 1 minus 2x. And you can replace that with an f to the negative 1. I'm not going to bother. But I need you to understand that if I had done this in a different order, just watch me for a second, guys. If I had done it by putting this one down first, 2xy plus 5x. Is everybody okay with what I did? I distributed that way. And then going this way, I had y minus 1. Then I had decided to move the y over here by subtracting it, and then subtracting the 5x over to this side, factoring out the y, and dividing at the end here by 2x minus 1. That looks very different than this answer, yes? But they are equivalent because if I change all the signs on the top, I get a 5x plus 1. I change all the signs on the bottom, I get a negative 2x and a positive 1. So it's my job to know that those are equivalent, but I just want you to realize your answer might look different than mine and still be right, okay? All right, can you try 10? How far can you get? This is a y, we're going to change the x and the y. You're changing all the x's to y's and the y's to x's. Cross multiply, and make sure you distribute correctly when you cross multiply. You doing this, Kaylee? I can't tell if you're even moving from here. You look like you need some caffeine. Okay, I would like one person to tell me which way you went when you cross multiplied. What did you put down first, Emma? Okay, so you went this way, and you did remember to distribute it correctly. So you came up with an xy plus a 7x. Going the other way, you'd just have a 2y minus 1. Did most of you do that way? Do that left to right branch first? Okay, I probably should have done the first one that way, but now what? Can I subtract the 2 y's over to this side? But what else do I need to do? Yeah, I didn't write that in a very good spot. I don't know if I can move it. I need to subtract 7x so that it's over here. All right, so I end up with an xy and a minus 2y on that side. In any order, you could write it negative 2y if you wanted. Plus xy. And over here, these are both negative, so no matter what order I write it in. Then the factoring step. What happens when I factor out a y over here? X minus 2. And finally, I'm going to divide out that x minus 2. So I have y, or if I want to get fancy, I can write it like that, by itself. And I have over here a negative 1 minus 7x all over x minus 2. It's actually much prettier if you change the signs top and bottom. You could write it as 1 plus 7x if you changed all those, and if you changed the signs down here so that you had a negative x and a positive 2, you could write it like this. Somehow that looks prettier to me, but it's equivalent. Doesn't matter which way you did it. Any questions? How many of you think you could do those if you follow that pattern? Okay, it is very much a pattern, okay? So you got to be careful. All right, you can verify that an inverse function, that two functions are inverses of each other by putting one inside the other, okay? In other words, the composition of a function and its inverse is always x. All right? So when you put a function into its inverse or an inverse into a function, remember how we did compositions yesterday? They would undo each other and all that would be left would be x. We'll talk about that in a second. Let's find the inverse of this function. So I'm going to switch this to an x and this to a y. And then I would like you to solve for y. So I would need to add the 6 to this side. And then I would divide everything by 3. I'm going to kind of write it like this so that we end up with slope-intercept form. So I'd have a 1/3 x plus 2. Is everybody okay? It's the same as x plus 6 all over 3. I'm just trying to make it so that we can graph it, okay? So the first function, I'm going to do this guy in green. Somebody tell me how to graph that. Y equals 3x minus 6. That is the tiniest graph paper. It's hurting my eyes. Sorry. Up 3 over 1, up 3 over 1. Maybe looks like that. Something like that. That's really bad, but it's so tiny I can't tell anyway. All right, and then we got this inverse function. The inverse is 1/3 x plus 2. So if I started up here at 2, it would go up 1 and over 3, or down 1 and back 3, and it should look like this. If those are correct, every one of the ordered pairs should have flip-flopped. So this ordered pair right here is 0, 2. Did we go through 2, 0 over here? Okay. This ordered pair down here was 0, negative 6. Did we cross back here at negative 6, 0? You get what I'm saying? Okay. It should look like it reflected across this line. Let me see if I can. Why is it giving me that? I don't want to pick a style. I just want to draw a line. All right, I'll just freehand it, and it's not going to go well, but it should look like it reflected or folded across the line y equals x right there. Okay, you don't have to write this down. I want to show you how you would test that this worked. You would take the original function, f of x, and you would put the new function in there. So you'd have 3 times 1/3 x plus 2 minus 6. And then you would take the old function and put it into the new down here. So you'd have 1/3 3x minus 6 plus 2. And they should undo each other. If I distribute here, guys, I get 1x plus 6 minus 6. Is that going to be just x? Over here, if I distributed, I would get x minus 2 plus 2. Is that just x? That's the work I'm not going to make you do. Remember I said there's one of the learning targets we're just kind of going to gloss over? That's proving that they're inverses, where you put one into the other both ways and prove that it undoes each other. I vote we just don't spend time on that. All right. Can you graph this? Can anybody tell me what shape that should be? Yeah, this is a cubic. You're welcome to use your calculator. Let's just put a couple ordered pairs in super fast. If I put a 1 in, what is 1 plus 4? If I put a 1 in, I get out a 5. Is that true, guys? Okay. If I put a 0 in, what do I get out? A 4. So I put a 0 in, I get out a 4. I'm listing these because we're going to want to check the inverse in a minute. And let's put a negative 1 in. What's negative 1 to the cubed? It is negative 1. So if we add 4, we get 3. Negative 1. Did I not go high enough? I think my points are wrong. I can't. Okay. Is this a line, though? It's not. If we put a negative 2 in there, we'd get negative 8 plus 4 would be negative 4. So by negative 2, it's all the way down to negative 4. It's very much doing this shape. It's just really hard to see, okay? But if you graphed it on the calculator, that's the shape it would be. If you switch x and y, first of all, what could we do to graph the inverse right now? Without doing anything else. What could we do to all these ordered pairs? Yes, we could graph 1, 5. I didn't switch it. I'm like, how's that going to work? Whoo, sorry. I think I had a little stroke there. 5, 1. 1, 2, 3, 4, 5, 1. 4, 0. 3, negative 1. And negative 4, negative 2. So negative 4 is all over here. Negative 2. So it's hard to tell, but it would curve through here like this. Now does it appear to be reflected across the line y equals x? Okay. I think we were supposed to come up with the equation. I switched the x and y, but I didn't finish solving. What 2 things would I do? Subtract 4. And then to get rid of a y cubed, I would cube root both sides. So I would end up with a y by itself and a cubed root of x minus 4, which is, the cube root shape is like this, and it's shifted to the right 4. That's the red one, right? Okay. All right. Is there anything more? Do you have this one? Let's show that they're inverses. Let's put g into f and just write 2 times x minus 3 over 2 plus 3. And then let's put this one in here because it's practicing what we did yesterday. You'd have 2x plus 3, then the minus 3 all over 2. All right, this was, let's see, I put g into f, so that would be this. Here I put f into g, that would be this. Do they undo each other? First, this would cancel here, so you'd get an x minus 3 plus 3. On this guy, you would do the top first, and you'd end up with 2x over 2, which is also just x. That's proving that they're inverses. I shouldn't have taken time to do the early one. I forgot there was one on here. Okay, you have to do this on the quiz. What are you going to do when it gives you a picture? Negative 3, negative 1, 2, 3, 4. If that's negative 3, negative 4, what's going to be on the inverse? Okay, negative 4, negative 3. And then if this point looks like 1, negative 2, it's going to become negative 2, 1. And if this point out here looks like 6, negative 1, it's going to become negative 1, 6. I don't know if that's accurate. And it would look like this, okay? So there's going to be a picture on a graph where all you have to do is switch the ordered pairs and you'll be good. Now did I cover them all, or is there still one more? Anyway, this one is actually not a function, but we could still graph the inverse. All right, the homework is all delta math, okay? Please use paper and pencil. You can't do all this by guess and check, okay?